Previously, on Free Return Trajectory.
Touchdown confirmed. Perseverance safely on the surface of Mars.
Something went missing. Something big went missing. Something like an entire comet. Things took an interesting turn. The mystery of the missing impact crater was just one more item that we added to the Mars mystery list. A few weeks after the quake was detected, Mars Express, an ESA spacecraft, started noticing something unusual. Here's a phenomena that's unfolding that piqued the interest of every single space agency on Earth. The E-Ring. It's home to 7 moons in the Saturn system. One of those moons is Enceladus, an icy world with a global ocean. An ocean not of liquid methane, but salty water. And it's this ocean that we have been studying for the past 2 years. We're located in an underwater habitat called CAR, Cousteau Aquatic Research Labs, named after the famous oceanographer of the 20th century, Jacques Cousteau. There appeared to be no active life in the ocean, even though we found lots of organic molecules. Recently, we're starting to see a certain type of grouping of these molecules. Large, complex hydrocarbon molecules are rare, but when we do find them, we find them in relatively large amounts. This may indicate that an unknown process is ever so often releasing these molecules into the ocean. This process must be relatively close by because these molecules didn't have enough time to disperse yet. We think that a potential source of these complex molecules could be in the many crevasses at the bottom of this ice block, which is 2,000 meters overhead. It's too risky to send our probes in these crevasses at this time. We'll make a note in our report for a more qualified research team to investigate this site further. We're only on a biosurvey mission. We have now concluded our survey at this location, so we'll move to our next location, 100 kilometers south of our present location. With not much to do until we get there, let's go back in time and continue the story of the events that led us to our sudden expansion into space. Dust devils. They occur all over the Earth, and they're independent of each other. Dust devils occur on Mars, and they're also independent of each other. However, numerous dust devils have formed in a specific area on Mars, and these dust devils appear to be converging on a specific small area on Mars, Aeolus Mons, the center bulge inside of Gale Crater. With such a strange phenomenon unfolding, every orbiter around Mars started to point their instruments and adjust their orbits to get a good look at Gale Crater, even if it's only for a few orbits to collect data using other sensors besides visible light. Sensors on the Maven spacecraft, for example, were used to measure changes in the atmospheric properties above Gale Crater. Mars Odyssey also used its Mars Odyssey neutron spectrometer, or MONS, to look for anomalies in scattered neutrons coming from the crater. This could indicate a sudden change in subsurface composition. As data from the spacecraft were analyzed by the various space agencies, it became very clear that the subsurface composition of Gale Crater was very different from earlier measurements. Israel first reported that they detected a drift in the orbit of their MOM spacecraft and traced it back to a mascon under Gale Crater. Mascon stands for mass concentration, a concentration of matter will lead to a higher gravitational pull, which in turn affects the orbit of a spacecraft as it passes overhead. And that's exactly what happened to MOM. Tianwen-1, the CNSA spacecraft, went into geostationary orbit around Mars, hovering above Gale crater at about 17,000 kilometers. This allowed it to monitor the crater at all times, at the great expense of gathering detailed data. The high-resolution camera on board Tianwen-1, called HIRIC, has a resolution of 2.5 meters and an altitude of 256 kilometers. So, at an altitude of 17,000 kilometers, this resolution is much, much worse. But since other spacecraft were orbiting much closer, this was a welcome move to gather additional perspective of Gale crater. As a quick note, the stationary orbit around Mars is technically called aerostationary, not geostationary, but everyone here at Carl calls it geostationary. We don't want to have to remember the unique names of all 8 stationary orbits around our colonies. Okay, so by now, a month after MOM detected the mascon, it was clear that something very recently changed on the Gale crater. And since there were no fresh craters, scientists hypothesized that magma from deep within Mars could have shot up into huge caverns under Gale crater, explaining the increase in local gravity. This event could have been triggered by the shockwave created when the meteorite entered Mars's atmosphere and potentially exploded in the air. If the magma hypothesis is true, then it means that a large amount of magma is able to move between the mantle and the crust, implying that Mars is volcanically active. Obviously, Mars is volcanically active since the eruption in Heloplanitia in 2058. But back in 2021, it was still unclear. A volcanically active Mars would force all of the space agencies to reevaluate the proposed landing sites of all of their future landing missions. This reason alone was enough to force the Indian, US, Chinese, and European space agencies to allocate more time on their respective orbiters for observing Gale crater. This included sending data back to Earth a lot more frequently. And that's when the strange event started happening. Some mark this event as the beginning of serious cooperation between all space agencies, which eventually paved the way for us to rapidly colonize the various planets and moons. But let's not get ahead of ourselves. The strange event that was happening has to do with the failure of spacecraft communicating with Earth at their scheduled times. Due to the very limited communication bandwidth available to spacecraft in deep space, spacecraft must reserve time with a communication network on Earth, such as the Deep Space Network, or DSN, as it's often called. DSN supports a little over 35 spacecraft. The spacecraft are located all over the solar system, not just Mars, the furthest one being Voyager 1 at more than 21.2 billion kilometers from Earth. With so many spacecraft using DSN, most deep space spacecraft get about 5 to 10 hours a day to communicate with Earth. Because of this, it's hard to identify the time a spacecraft starts experiencing problems. And without a communication link, it's almost impossible to determine what went wrong. The first spacecraft that failed to communicate with Earth was Mars Express. A day later, MOM stopped communicating. Then MAVEN, then the ExoMars Trace Gas Orbiter. The fact that multiple spacecraft were lost within a short period of time most likely indicated that the cause of the disruption was a common external event. The most plausible source that can create an event that could affect multiple spacecraft in orbit around Mars is the Sun, through solar activities such as very strong solar flares and coronal mass ejections, also known as CMEs. In both cases, spacecraft around Mars would receive a much stronger than usual electromagnetic radiation. This radiation would also easily be detected by our satellites around Earth or in heliocentric orbit. But flares, or CMEs, were not reported. By the end of the 6th day after Mars Express was lost, Contact with the rest of the orbiters around Mars were also lost. That includes the Emerald Mars mission, Mars Odyssey, and the Mars Reconnaissance Orbiter, or MRO. Now, the loss of MRO was especially devastating to the international effort to gather information about what was now being called the Gale Crater event. MRO had the largest telescope ever flown to Mars at that time. It could resolve down to about 1 meter per pixel. Repeated attempts over the next few days to communicate with MRO failed. There was even an attempt to use Perseverance and Curiosity to communicate with MRO. Under normal conditions, NASA rovers would use MRO as a relay to communicate with Earth. But each rover can communicate with Earth directly, but at a much lower data rate of 32 kilobits per second. That's the maximum data rate, but under normal conditions, it's only 500 bits per second. So what NASA engineers tried to do was to get MRO to transmit its telemetry data to one of the rovers and then have the rover relay that to Earth via its slow but functional communication X-band channel. The assumption was that if the main MRO transmitter to Earth had failed, but MRO was still functional, then the UHF channel could be used to communicate with the rover. If this did work, MRO would still only have 8 minutes a day to transmit data to the rovers due to its orbital motion. But that's better than nothing. But in the end, this didn't work, so it was nothing. Curiosity, Perseverance, and even InSight could not detect MRO, or any of the orbiters for that matter. We've had orbiters around Mars continuously since 1997 for 24 years. But now, they appear to be all gone. What was really bad about losing all the orbiters was that we didn't know if something in orbit of or near Mars was causing the spacecraft to fail. Without knowing this, it would be very risky to send new spacecraft to Mars when the Mars launch window opened up again at the end of 2023. But luckily, there were no Mars launches scheduled for late 2023. The only way we could now look at Mars from above our atmosphere was through the Hubble Space Telescope, located in Earth's orbit, too far to get any meaningful data about the Gale Crater event. The James Webb Space Telescope was still about 6 months away from launch, and it wouldn't have been much better. At a time when the world needed an eye on Mars, 7 orbiters were lost in 7 days, leaving Earth blind when it came to looking at Mars from orbit. Actually, almost blind. The Tianwen-1 orbiter in geostationary orbit was still in contact with CNSA, but since it's not part of the Mars Relay Network, NASA rover wouldn't be able to use it as an alternate relay station for faster communication. At a distance of over 17,000 kilometers from the surface, localized detail was lacking from any data collected by Tianwen-1 regarding the Gale Crater event. So, we're left with only 4 pieces of hardware on Mars. InSight, a stationary seismic platform, Curiosity and Perseverance, 2 rovers powered by radioisotope thermoelectric generators, and Ingenuity, a rotary wing aircraft untested on Mars. All of these hardwares are located on the surface of Mars. The question that every space agency is now asking is this: what is the safest way we can use these 4 hardware to monitor the Gale Crater event as it unfolds?